Hey guys, Michal Hucko here and welcome to another lecture of our course Classification in Python for the Beginners, where I'm showing you practical applications of Python libraries to classify data. In this course we are classifying the HR case study from the Kaggle, so please join us on this beautiful adventure. Let's go to our next notebook, which is called 005 Final Preprocessing. For those of you who are going along with the code, you can find the code examples linked in the description below on my GitHub. Please feel free to follow my GitHub, and let's go back to the notebook. So in this video, I'm going to show you how we can connect or apply the preprocessing mechanisms, which I showed you in previous videos, together to predict on the dataset. And I will show you how application of these preprocessing methods can improve classifiers or the machine learning algorithms, like in this case the logistic regression, to make some better predictions, right? So as you can see here in the first cell, I'm importing here bunch of classes from the scikit-learn. And for those of you who are new to scikit-learn, I'm telling you, you will see this scenario always. Everybody is importing everything in the first cell, so this is a good practice. And whenever you will find, for example, here the standard scalar and there was nowhere the definition above, you can always go here to the first cell, look for the standard scalar and see from where was originally the standard scalar imported, right? So I highly recommend, before moving on into any of these examples, go through the modules and through the classes which I'm importing always. Right, so first of all, I'm reading the data frame from the CSV file, data general data.csv. Then I'm dropping the unused columns, and I'm also dropping the rows with the non-values. Further in next lectures, I will show you how you can apply different mechanisms to these non-values, which is also a part of preprocessing. For those of you who don't know anything about the non-values, I highly recommend my previous course about pandas basics, where I'm talking about non-values and handling the non-values, right? So now I'm also splitting the columns, as I did in the previous lecture, to categorical and numerical columns. And now, as you can see, I'm creating for each of the preprocessors a specific instance, which I'm assigning to a variable like scalar, polynomial for polynomial features. Here I'm setting the degree to 3, and I'm also setting the encoder to one-hot encoder, and I'm turning off the sparse matrices because I don't need sparse matrices right now. We don't have so much data. Right now, many of you may ask yourself like, okay, Michal, but what is too much data? Now, you will find out what is too much data for your computer when you will reach a certain limit in the computation of your computer, when the computer will just start to overheat. It will take many hours or many minutes to predict something, right? And in this moment, there is too much data for your computer, right? Then you need to buy a new computer or run it somewhere else, or just wait for the results, as I always do. Right, so let's go back to the prediction. As you can see from the data frame, the original data frame, I'm putting away the attrition, which is the target value which I want to predict. I'm setting the attrition here. It's always important to put away the target value. When you will forget about this, and you will predict, you will suddenly have 100% of everything, and you will be like, man, I'm good, my classifier is predicting on 100%, and basically you will have a wrong classifier because it was just predicted based on the target value, which was already presented in the dataset, right? So then I'm setting away the target value into the y vector variable, and then I'm splitting the dataset into the train and test set based on an 80-20 rule, as I mentioned in the previous videos. Now, what is next? I want to train the logistic regression. Now, for those of you who don't know what is logistic regression, you don't need to worry right now, yes. I will explain the logistic regression in next video. Well, to be honest, this course is more like a practical application of machine learning, right? It's not the mathematical statistical part where I'm going to talk about the theory of algorithms of machine learning and I'm gonna bore each of you. You will just turn off this course and go away and never come back. No, I want to make this as engaging as possible with the practical examples of the machine learning algorithms from Python. So I will just keep the scope of this course to the practical applications. Yes, in the next video I will just talk a little bit about the algorithms, but it will be just an easy explanation for each of you because, you know, I would like to everybody to understand these videos and make them as simple as possible, even for my, I don't know, mother or father who is watching this, okay? So let's go back to the training data, and here, as you can see, I'm using the feed transform method for the numerical columns in the X-train in the first case. So I am training the polynomials so I can later apply it to the test set, right? And then I'm setting the results into the polyvariable. I'm doing then the transformation for the polynomial variable with the standard scalar, and then I'm saving the result into the scaled variable. And the same thing I'm doing for the encoder, which is just one hot encoder in this case, not the label encoder from the previous video, okay, beware of it, to the encoded variable. And then as you can see, the numerical shape in this case is 560 columns. Now, quick pause and a small question. Why there is so many columns? And the answer for this is because I set the polynomial features to 3, right? If I set it to 2, you will have less columns, and if you set it to 1, you are not applying any polynomial features at all, right? And then in the next row, I'm like concatenating the scaled and encoded like data frames into one data frame, and that's it. That's the shape. Well, to be honest, this is not a data frame; it's a NumPy metrics. So like if I go like unit. Oh, sorry, you need to run everything. Yeah, and as you can see, it's an array of arrays in NumPy, right? But you can still convert it into data frame if you want. But I prefer to work with NumPys. Fine. So we have this transformation, and now I'm applying the transformation to test. And notice the difference. Besides calling the feed transform, I'm just calling the transform function for each of the preprocessors, right? And then at the end, I have the test set, which has the same column number as the training set. Well, is decent, Michal. What's next? Now we are going to compare the performance of prediction on the logistic regression without the preprocessing and with the preprocessing. Now, logistic regression is my favorite. I did a master's thesis about logistic regression and applications of it to predict the emotions. So it's like my first choice. Logistic regression is a simple algorithm, it's very fast, but it's very effective, and it's used nowadays in production code a lot. Now, how you can use the logistic regression is as simple as setting the logistic regression here, and now as you can see, I'm not using the X-train pros, but I'm using the X-train variable, which is the original data frame without any custom preprocessing, and I'm predicting on the X-test, and as you can see, I'm unable to predict that somebody will go away from the work. So I have 0 precision and 0 recalls. I never predict that somebody went away. So basically what I just created here, it's something which is called one label classifier. So if I will look inside the y pred, sorry. So if I go inside the y pred here, you will see that there will be only no's, right? It's a good baseline classifier. If you can predict, you are creating at least something, but our classifier is predicting basically just still no. It's as good as me, right? So I can be even better sometimes. So now, like, well, we need to transform the data, right, in order to help the logistic regression, Michal? Answer is yes. So if you look at the logistic regression with the X-train pros, which is the processed data from the numerical and categorical attributes which I showed in the previous videos, and I'm running the prediction, you will see that suddenly I have some great precision numbers even for yes. And I have some recall. Yes, it's not the best, right? The k nearest neighbors was better before, but well, we are getting somewhere. So the purpose of this video was to show you that some of the algorithms are unable to predict without any preprocessing, right? The k nearest neighbors is like, well, it's good, it can work with a lot of data, you don't need to preprocess anything, right? Or maybe I was just lucky with the dataset, who knows? Maybe for the project you will do something with your own dataset and you will suddenly look at that and the KNN will return nothing, right? The k nearest neighbors classifier will just always predict no, right? So in that case, I will try to apply the preprocessing or the different algorithm well. So you always need to know how to preprocess data. And as I showed in this video, by applying the preprocessing to the data, I was able to improve the logistic regression, well, significantly. I get from nothing to at least somewhere. Well, and the f-score of 0.9.0, it's quite good. It's quite good. So guys, thank you very much for watching this lecture. I hope I will see you in the next lecture.